When it comes to point level or on-off level measurement, process coatings can be a huge nuisance. The scenario is all too familiar. Tank fluid rises and makes contact with the probe, and an alarm is signaled as it should. The problem arises when the process media drops back down and leaves a coating or film on the probe, leaving the probe in an alarm state. An obvious false alarm. Traditional capacitance probes are two-terminal style probes. They're called two-terminal because they consist of two electrical elements, ground and an active rod. When using this type of probe in a conductive product, the process media rises and touches the probe. This contact completes a conductive path from the active rod to the metallic tank wall, allowing current to flow from the probe to ground. This current flow is detected by the electronics and an alarm is generated. As you can see, there are multiple paths that current can take, all going through the process media. When the liquid drops back down and leaves a coating, the current paths through the process material are broken. However, there is still a path to ground from the active probe back to the tank wall through the coating. This causes the electronics to maintain a high level of indication or false alarm when using a traditional two-terminal style probe. Drexelbrook pioneered the use of Cote-Shield technology as the solution to tackling this problem. Cote-Shield technology allows RF capacitance probes to effectively ignore coatings to prevent false alarms. With Cote-Shield technology, our point-level devices are able to distinguish between a coating and when process media is actually covering the probe. A probe with Drexelbrook's Cote-Shield technology is known as a three-terminal probe. This probe consists of three electrical elements: ground, an active rod, and of course Cote-Shield. When the liquid rises up and covers the probe, an alarm signal is generated just as it would with a two-terminal probe. Now, watch what happens when the process media drops back down. No alarm. The reason for this is that the Cote-Shield element is blocking the only remaining path to ground. Remember, for an alarm to occur, an electrical circuit needs to be completed from active rod to ground. Without the liquid covering the probe, the only path available is from the active rod through the coating to ground. But with Cote-Shield, that path is blocked. How is this done? The Cote-Shield and active rod segments of the probe are at the same voltage potential. When 2 points are at the same voltage, there is no current flow. We've essentially created an electrical check valve. This stops current flow from the active rod through the coating, leaving only one alternative: through the process fluid. For Cote-Shield to work effectively in your application, we have one very important rule. The Cote-Shield needs to extend into the tank past your installation nozzle and any wall buildup by at least 2 inches. Let's see an example of what happens when this rule isn't met. When Cote-Shield is buried inside the nozzle, we are essentially bringing ground closer to the active rod than Cote-Shield. This creates a more effective path to ground and bypasses Cote-Shield. This is why it's important to have the Cote-Shield portion of the probe extend past the wall and any wall buildup. This places Cote-Shield in the direct path between the active rod and ground. Our reliable point-level devices have been installed in more than 100,000 systems worldwide. They are proven over years of extreme tank conditions and trusted by some of the largest companies in the world. Reliable, proven, trusted level measurement solutions that you can depend on.